All right, standing room only crowd. This reminds me of 3:30 when we do mini sessions. Shameless plug as chair of the 3:30 committee. We have a couple nice mini sessions on Wednesday morning. So I do have the unenviable position of following up Kevin, who seems to always find a way to pull jokes out of otherwise quite nerdy topics. So we're going to be talking about me being, working for a contractor, some challenges and opportunities that we face, right? Because what at the end of the day do contractors typically deal with that the designer, even the general contractor, but us as a concrete contractor that we deal with, that regardless of what gets specified, we can't seem to fight our way out of? It's a 4-letter word, right? Risk, right? At the end of the day, somebody specifies something, it's like, ooh, I want that pretty new little toy. And then we have to figure out how to put it into place. But as Kevin really put very well, we don't really understand what it is that we're putting into place. It's just this new shiny toy that we want. So we're going to talk today a little bit about the challenges. Whoever's over the next door is apparently doing a really good job because there's a lot of laughter. So if you're looking for a seat, I would recommend going over there because you're probably not going to get a lot of jokes out of me. We're also going to talk about some opportunities, except for this presentation in general. And then we're going to talk about some of the responsibilities at the end of the day. So the first challenge that I always like to bring up, as contractors, there's a lot of things that we can do to provide input into what ultimately gets designed and built. But one of the things that impacts, at least as I see it, our ability to really bring to market the potential for reduced embodied carbon solutions really kind of starts with our codes. And, I'm going to bring up a very simple starting point and say, how many slabs do I see that are designed, quote unquote, per 318, but that do not transmit any vertical or, transverse loads from the building to the soil, right? We see it all the time, and there's lots of things that are embodied into those designs. You like how I use that word? Into those designs that really impact the embodied carbon of the design. And a simple solution may be to look at, for instance, ACI 360, which is where we should go for the design of these slabs. And we can then even further some of that technology for some slab systems that are out there on the market that we'll talk about a little bit later on. But in reality, when I ask engineers these questions as a contractor, one of the biggest responses I get is, well, we have to do what the code tells us to do. We don't feel comfortable. And I'm like, you do realize that there's like this little line in the code that says we can do something different. They're like, yeah, but our attorneys say not to read that one, right? Again, they are dealing with their own level of risk as the design professional, which impacts the designs that are placed out there for us as contractors to bid. We also have challenges looking towards low carbon alternatives with specifications. How many specs do we read that say 4-inch slump max and no use of high range water reducing admixtures, right? Lots of them. So how do I place concrete in something where I really need more than 4 inches of slump? And don't get me started on the concept of slump, but let's just say 4 inches of workability to this concrete. But I have specifications that really kind of preclude our ability to do that, right? Or we have a maximum water to cement ratio without a stated durability need. I have one of these on a massively large automotive project that we're working on right now, where we have an engineer that has specified some random maximum water to cement ratio, and I submitted 3 RFIs trying to go back and forth with this engineer and saying, can you give me a durability classification? Nope, don't have one. Well, why do we have this water to cement ratio? Is there something that I can't see? Because, the owner has very clearly stated that they have some objectives that they're trying to get to, X, Y, and Z. No. And then finally, the third response comes back, you need to stop asking questions and do what I tell you to do. Thank you very much. We will respond back to the owner that we cannot hit their durability requirements accordingly, and they're going to have concrete with a higher embodied carbon than they would otherwise necessarily need to. Supplementary cementitious materials not being allowed. We saw that same thing on this job. And then also what happens when we have maximum cementitious contents and or replacement limits. Sometimes we see the opposite thing where we have minimum cementitious contents, where we don't need to see a minimum amount of cement, or the minimum amount of cement is significantly greater than what we need for the project. At the end of the day, what we often see, though, with regards to our specifications is a cut paste, right? We're hitting the easy button. We're taking the last few projects we've done. What's even more interesting as contractors is when we can really begin to read and see where we've cut and pasted from multiple different projects set of specifications into the current set, and we have conflicting language. That becomes even more interesting within our project specifications, which provides another level of complexity that we have and a challenge that we have as a contractor. So we also see that within the realm of construction in general, not necessarily related strictly to the designer, not necessarily related strictly to the owner, or even at times, admittedly and very admittedly, the contractor themselves, is there is a resistance to change, right? We all as humans get comfortable doing things the way that we have always done them. We know that they work. We know that they limit our risk. They minimize our liabilities. So why do I need to change? And, Kevin did a really good job of kind of tee this whole thing up, so I'm not even really going to kind of get into why we're being forced to change. But what I'm going to say is this. With things out there forcing us to change, forcing us to modify how we look at the materials with which we build, how we build with them, and what those impacts are beyond those two things, we have got to move beyond this resistance to change that we all have. And I love, I'm in the process of this right now with our own internal, architecture and engineering teams. Like, will you please just listen to me? Right? I'm just asking you. I am not going to bring something to you that we have not already vetted out initially that we think is going to meet muster and not increase liability. We think this is going to be a better solution, right? But then it's always that resistance to change that we face. We have challenges of the financial focus. Wow, I'm already putting somebody to sleep. I've gotten the first snore already. So our financial focus is another challenge that we face. I can't tell you how many times I've had a meeting with a developer, and ultimately, on paper, they're asking us to do X, Y, and Z, typically related to sustainability, typically wanting to look at lower embodied carbon alternatives, reduce GWP, reduce acidification limits. We've kind of seen all of those things specified, right? But on the other hand, we're like, man, we've got a lot of different things that we can talk about. Some of them may extend your construction schedule. Nope, not interested. So, or sometimes we have the conversation and they may be a little bit more expensive up front, but we can show you through some calculations through building use cost and things like this, where the long-term benefits are there. There's a lot of developers that we have to realize that are asking for certain things and are now potentially going to be forced to build with certain materials, as Kevin stated, because of state laws and other things of that sort, which for owners who are not focused on the long term, for developers who build and flip within a year, 2 years, 3 years, this is going to do nothing more to them than increase their upfront cost, which becomes another strategic problem for them to have to focus on when they're going through financing phases on these projects, right? And it makes it really difficult for us to be able to propose some alternative design materials and methodologies to address this issue. Let's talk about simply, the lack of clarity around standardization of what really does a low carbon built environment look like. Like, everybody's heard of LEED, right? LEED. It's the rating system owned by the USGBC. But look at all these other little logos and names and stuff. I mean, did y'all know that all of these other things are out there? I mean, there's tons of them out there. So who standardizes? Like, who says, I'm LEED, I'm right. Nope, I'm BREEAM, I'm right. I don't even know what BREEAM is. I've never even heard of it, right? But who is looking at these and saying, no, this is objectively the right path or a better path. I don't necessarily think the right path is a fair word to use, but I would say an objectively better path to use if we want to achieve a particular goal than a competing organization's methodology. But what it really does is provides a lot of confusion, not only to the design, but to the contractors and also the owners in how they are trying to, for lack of better words, promote their own end goal of being a more responsible steward of our environment. You know, I sometimes like funny pictures, and sometimes I like pictures that make, kind of an idea. We got to move beyond this conversation of cement being the same as concrete. Literally just got an email from one of our executive leadership team members asking if we can internally help explain to our executive leadership team about how concrete isn't bad, right? How cement isn't bad, right? And I think Kevin did a really good job of that, talking about the comparison and kind of what I would almost say is the inequity between concrete and steel, right? There's also a very, very wide inequity between what asphalt has to consider from cradle to grave. We do realize asphalt's cradle to grave is not defined the same as concrete's cradle to grave, right? So there's a big inequity there as well. But first of all, yes, cement may have a very large, within itself, carbon footprint. But that doesn't mean that on a per volume basis, concrete has the same. As a matter of fact, it is significantly less. And we really need to work on controlling the narrative and changing the narrative. And the NRMCA and the PCA are really working on this very diligently with the design community out there because, hey guys, if we want to talk about cement, that's fine, but that's cement, right? It's not concrete. Concrete is not the devil. We cannot build the buildings that we have today without concrete in some way, form, or fashion. I would challenge anybody to figure out how we do that. And I'm going to throw this caveat in there because this is the caveat that gets thrown back to us as a contractor all the time. And do it and meet the same construction schedule. And do it and meet the same building cost. So that's my challenge. When we can do that, then I'll feel free for everybody to walk around demonizing concrete. So we also have other challenges in the materials, right? And there's risk and reward in new materials that are being brought to market. And again, thank you, Kevin, for doing such a great job of talking about this because I really don't have to spend that much time. But man, like binary cements are here, right? The 1Ls and other forms of binary cements go out west. You find 1Ps, there's some 1Ns sitting out there, right? But ternary cements are coming. I mean, in some markets, they're already here as the standard, especially as we move out west. But there's two real important things to understand and consider as we look at changing cements. First of all, it's not just about the cement. There's a lot more to that cubic yard of concrete than the cement. There's a lot of things that we can do to optimize that mix for performance that lowers the cement utilization, but it's not the cement. The thing is do we want to spend the money to do those other things? I mean, we can begin blending aggregates. We can use aggregates that aren't the cheapest aggregate per ton at the plant, but have a lower water demand. So that means we have a lower paste demand, right? But the other thing to understand as well is that material changes bear more risk to some elements than they do others. And this is the real big thing that I'm trying to get people to understand. Like honestly, I've said it before. You want to use a 1L cement? I don't necessarily mind, and don't really care that one day your cement's a 8% and the next day it's a 14% replacement if I'm putting it in a footing as long as I make strength. I don't really care. Put it in a wall? Great. Don't give me a bunch of shrinkage cracks. Let's talk about a little bit of thermal change when I strip the wall forms off. But other than that, I'm pretty good to go. Put it out on the 80,000 square foot slab pour. Now we have a whole different conversation, ladies and gentlemen. And I think that that's really where The biggest risk from a contractor comes in is that understanding what elements that we're building and what levels of risk that we have with those elements, what the changes are in the materials that you're wanting to propose for the project have to do with that element, and the fact that we have to understand that we have to move beyond lab testing. This concept of doing all this testing in the lab, and we've done this for 10 years, and we've done this on roadways, and we've done this in soil cement stabilization, and we've done this on whatever else because we've got some, lab cement that works great, that's carbon negative, as Kevin maybe said, right? That's great. But how many full-scale field trials in multiple climatic regions around the United States have we really done with this material? How many times have you reached out to partner with a large flat work finisher to understand what the impacts are going to be? Because at the end of the day, you're not the one who really holds the risk. We are. We've got that contracted risk at the end of the day. And that's a big thing for us to understand. So, another challenge that we have simply deals with speed to market. Developers want it faster. Faster, 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 faster. Can't say too much. Been a really eye-opening experience over the last 4 months getting to come to work with the contractor that I work with now and looking at who our client base is and understanding just what the owners want. It is all about speed. So much so that we're happy to send all the kindergartners into the room together with battle sticks and let us fight it out to see who's the biggest, baddest, and strongest and who can remain standing in the kindergarten classroom at the end of the day. But that's not how we should build, right? We should really think about what our approach is and understanding that sometimes faster is not necessarily better, right? But there's challenges in this design phase that's going to impact speed to construction, right? Of construction and speed to get to the end of the process. There's things that we can do in the budgeting phase, right? But again, we all have challenges in that budgeting phase. How do we, as a concrete contractor, really promote what we can do and get it past that general contractor level, up into that designer level, and then up from there to that owner level so that we can begin having conversations? And then we have challenges in the construction phase because sometimes the thing that everybody has decided to do has an impact to something else that's going on with that slab. I am a huge proponent of shrinkage compensating slab designs in construction. Huge component. You really want to look at low embodied carbon. That's the first thing that you can go and look at right now that could very potentially begin to start cutting some of your embodied carbon, right? Because with the appropriate design, you can thin slabs because we're reducing curling. We're replacing Portland cement or Portland limestone cements with a type K cement or a similar type of expansive medium, which typically often have lower GWP and lower, other forms of methodologies of looking at embodied carbon and things of that sort than our PLCs or our type 1-2 Portland cements do. So there's a lot of options there. But why don't we look at shrinkage compensating concrete construction a lot? It's that little thing called a wet cure. And we just can't move beyond that speed of construction mentality, right? So there's trade-offs and everything. And at the end of the day, the current project delivery system is really just not suited in the United States to lowering the embodied carbon in a risk-sensitive industry. The chain is broken. How we get from concept and what an owner expresses they want as far as reducing that embodied carbon in the built structure to getting it done really is broken, right? So what are some of our opportunities? And what I would say is a lot of that opportunity exists in shifting the dynamic and the narrative in project delivery. It really starts here. The most common methodology that we have in today's built environment is design, build, bid, build, right? I'm going to design it. You're going to bid it. We're going to take the absolute cheapest price that we can get, and then we're going to go off and build this thing. I can tell who the contractors are in the room now because you're the ones laughing. So see, Kevin, your jokes are so much better than mine, even though I'm looking at all the contractors laughing, going,
for my height.
Is that it? Oh, now we get Kevin's short joke. Good job, Kevin. Being tall is not all that great. Go walk around Wares Valley, Tennessee, and you'll understand it. But what this really does is the concept here is if we pit all of these contractors against each other, we're going to get the best price that we can. Do we often see that that's really what the solution is, right? Are you really getting the best price? Because given the current methodology of getting the plans and specs out as fast as we can, having everybody kind of bid off of a paper napkin just so that we can say that we're moving the project forward, and then circle around to what it really takes to get the building built, are we really getting the best price for the client as possible? And we can transition these project delivery methodologies over to really what we see in place more so in Europe and other areas where we're having more of an integrated delivery, where we have the owner involved with the designer, with the GC, with the specialty subcontractors that are your larger, typical cost driving, schedule driving specialty subcontractors. And when we can get everybody working collectively, it is absolutely amazing to see some of the things that we can do, that we as concrete contractors can bring to the table. And when we can get that direct line of communication with all parties who have a stake in the project, it is a beautiful thing to see when everybody is acknowledging, accepting, and owning certain risks. We're transferring risks from some parties to the others from other parties back to other parties where they should all be, but we all get a collective agreement on what we can do. And when we can get to that level in the project delivery narrative, it is going to be an amazing thing what we can do with the materials we have available to us right now, that we have experience working with right now to lower the embodied carbon in the building right now. This is really what I see is one of the biggest opportunities that we're missing out on. And what I think is driving this mentality is that we just have flat out a level of distrust within our general industry, and that's why we design bid build so frequently. And what this really does allow us to offer is alternatives. And I referenced this section within the 318 code earlier, right? 110. It allows the possibility of alternative systems of design and or construction and alternative materials not covered by the code, right? But it also means that sometimes somebody is having to assume some risk. And even it's that somebody who's passing it off on a delegated design system, right? I'm a huge proponent of delegated design slab systems. Moving into the world of delegated design structural systems, the more that I am beginning to look at some of the work that's being done over in Europe with some of the very unique structural reinforcement systems that they're doing in Europe. But right now, our code just doesn't necessarily explicitly acknowledge that, hey, we can do this, right? I'm the engineer of record on this job. I'm going to go over here and use this delegated system, but we still own some responsibility of working with that delegated designer as far as how that one element works and integrates back into the overall project. But there's a flourishing of new technologies that have occurred, and it really started with Ductilcrete some 10, 15 years ago in what I will say on the slabs on ground and what they brought to market that really kind of changed a lot of the narrative with regards to delegated design in the constructed building environment with regards to concrete. And since Ductilcrete, you have other people who have brought synthetic fiber reinforced systems to the market. Forta with their OptiPave system, or now they own the rights to the OptiPave system. Full Force, who has a number of systems that they've brought out both in pavements and in slabs that are delegated design system approaches. They take the whole design of the system over with being provided all the design load criteria, reviewing the geotechs themselves, turn around an entire design and specification package. They integrate back with a structural engineer of record. in making sure that they've taken into consideration all the other things that are out there. And as the contractor, being that we're bringing these people to the table, we get to have that narrative back with our designer very closely to understand and optimize the concerns with constructability, so that we understand very specifically how can we look at all of these express needs of the client, the owner, and figure out how we fit that into something that can be built faster or for the same time, potentially with a lower, embodied carbon. And quite honestly, one of the things that I've always been a huge proponent of, and I'm very glad that our mother company, Gray, and us as NextGen are a huge proponent of, is simply looking at the safety of what's being designed and how we're going to have to put our people out there in the field building what's been put on paper. Sigma Slab is another one. If you're not aware of it, it's a really unique system. It's a partnership between Beckert using their Dramix fibers and CCL using post-tension in that form of a conversation. So that's a really neat system that's out there and available as well. And then I'm just going to go on record because everybody says I'm a homer. All right, fine. Publicly, I'm saying it. I really think Primex in a number of situations out there is one of the most underutilized slab systems that's available, especially for your heavily loaded slabs. If you're out there looking at double mat steel slabs, heavy industrial slabs, things like that, the ability that we have and what we can do with Primex with regards to speed of construction and safety of putting our people out there trying to place and finish concrete is a pretty significant improvement. But the other opportunity that I will say as a contractor, anybody, I'm going to give y'all just a couple of seconds to guess what picture I may be putting up next. Any guesses? Not mine. I do not fit into this. Now, Ryan back there, he's the dude, right? So, I grew up in the 80s and 70s. I know I don't look like it. I'm pretty young looking baby, right? But this is the man, right? The cream's going to rise to the top. And we know that. And everybody remembers, right? We had a little creamer. We were sitting right there on WWF, baby. We were rocking it out. But as Randy Macho Man Savage said, this is really an opportunity for contractors, the cream of the crop of the contractors, to take all of these things that we have been working with, all of these systems, and we're going to go out here, with a Ford F-150, and an old beat up, 2x4 and whatever, and place and finish concrete. I'm talking about your real contractors. And this is really an opportunity for the contractors out there, and I'm not even going to get into naming names because most of them are sitting here at ACI, right? If you're sitting here at ACI, you probably fall into this category. But for us to move ourselves above the rest and be able to promote what we can bring to the table that differentiates ourselves from other contractors out there. But we all have to be open to new ideas, and that's a responsibility shifting into this phase now. We all have to be open to new ideas. That's owners. You may have to be open to the fact that it's going to take you a couple more weeks to get your building done, right? It may take you a little bit more money to get this done. But if you're going to hold on to that building, we can explain to you where spending that money now is going to have a big benefit to you long term, right? We deal with situations and trying to move these things upstream with GCs that really aren't interested or don't want to be bothered with alternative systems because, man, I ain't got time to deal with that. Just bid the design and we'll figure it out later. Well, we all know that figuring out later never happens, right? But we all have to be open-minded in our approach to bringing new technologies to the market so that we can look at lowering the embodied carbon of these structures with the materials that we have today, because we can do it. And it's pretty simple. If you don't ask, you won't know. So I ask questions a lot of times, right? Because I never ask a question of the person that I'm working with. I never know if they're going to be open to a new system, right? We have to be solutions driven. And Einstein had a pretty unique comment years ago, or quote years ago, that I think, this is one of the ones that I keep in my files of things that, that I use in presentations, which is, we can't solve our problems with the same thinking we used when we created them, right? And if we can't change to be solutions driven today, instead of just thinking about how we've always done things, we're never going to get out of our way in solving our problems. I leave you with this. If the real opportunity that we all have is really a responsibility of everybody in this room. And that is, we have to agree that we want to be a part of the solution. We don't want to be a part of the problem. We want to be a part of the solution. And depending on what your role is in this whole process, being a part of the solution means a different thing. But for us, I think that means we have to be able to know how to build, but we also have to be ahead of ourselves in understanding the technologies that are there so that we can propose them to other people to understand how we can do things differently right now, that we can communicate back with the general contractor, that we can communicate back with the other trade partners on a job, that we can communicate back with the designers and with the owners so that we can answer all of their questions. That's really how I see us as a concrete contractor being a part of the solution and not continuing to be a part of the problem that we have today. So that's it for me. 30 minutes and 39 seconds, baby. Bam.
All right, does anyone have any questions for David before he heads out?
I just have one question. Thank you for the presentation. I want to create a challenge for you, and now you are saying you want to do the delicate design. I'm a sort of engineer record. But the typical contractor's warranty is about 5 years. If we go with your idea, we have to do the performance-based design. Service life for building is 50 years or to 70 years. Bridge is 100 years. And after 5 years, you walk away. How do I know the performance, the structure would last until the designated service life? Say right. 50 years later.
So good point. And I'm going to attempt to summarize this. Your question is, as a contractor, we typically have a contracted warranty, effectively, on what we build, which typically, by the way, in most states is 1 year, not 5. If you'd like for us to do a delegated design system for you, you can definitely purchase a 5-year warranty from many of the systems that we work with, and we would be happy to talk with you about that. But there is a fundamental difference between like a warranty versus the service life design of a building, right? Because typically I'm going to try to answer this in the way if we are going to have a design failure or a construction failure, it's going to show itself in the first year. Otherwise, I don't know that there's necessarily a direct correlation between like a warranty period and a service life, a design service life. Are there any attorneys in the room that would maybe like to answer that question? So, did I answer your question? Here's what I'll say. I'm a materials engineer, and I like to think that I do a really, really, really good job, even to the point sometimes of ticking off some of the vendors that we choose to work with, because I do really get into the weeds with them. Kevin, is who just left and presented before me. He has the contract as the engineer of record for Primex for North America, and he and I have gotten to know each other really, really well over the last number of years, and we have a great respect for each other because at the end of the day, we want the same thing. And I challenged Primex very deeply and directly because a lot of what they're doing is stuff that nobody else in the world does, and a lot of what they hold very tight to the chest is extremely proprietary, even to the sourcing of their materials. They hold the entire exclusive rights to certain sourcing. So just understand that some questions that you may have, you may not be able to get the answers that you want because some of the things are very proprietary. But as far as their methodologies for design, they're very open book about that because they have to be.
But a typical concrete structure would have long-term effect. It would be stabilized 5 years. I've heard lawsuits sometimes happen around 5 years, but you walk away after a year. The owner still is that who will be responsible for the sale.
Yeah, so understand that a lot of what we're talking about for the delegated systems today are like foundations or slabs on ground. Sigma Slab, of course, is going vertical with, a post tension and steel fiber reinforced slab alternative. And I'll, you can reach out to CCL and talk with them about that. Primex has just gotten through with a full scale, multi-story, full, like I said, full scale structural load test in Europe. Very interesting. You can go online and look at that, getting away from bar and into fiber. So I would definitely look into them.